In this module, we'll take a look at different types of home heating systems. There's quite a variety of these, including electric resistance heaters, wood-burning stoves and fireplaces, ducted systems or forced air systems, hydronic systems, and heat pumps. Direct electric systems, or often referred to as electric baseboard heating, use electrical energy and a resistor to create heat. The heat is often fairly expensive overall because of the amount that's used, but the overall initial installation cost of these systems is relatively low. They include baseboard heaters, fan converters like this, radiant systems that are embedded into floor systems, as well as different types of wall-mounted systems. One of the benefits of these types of systems is that they do provide localized heat and they don't require ductwork, refrigeration lines, or plumbing. They are often used in kitchens and bathrooms where sometimes forced air systems can be challenging to install. And when there's an addition to a home and it's not practical to extend the existing heating system, we may use electric systems to provide heat into the addition. The overall benefits of these systems are really confined to the fact that they are fairly low cost to install, and but overall they tend to be associated with a high cost of operation. Electric space heaters can be used in a home that's centrally heated, but in perhaps some places the central heating isn't getting the job done. This could be from a lack of insulation or air leaks, and they're often a good starting point for a conversation with the homeowner about how the home's overall thermal performance works. Convection units rely on rising motion of air around them. Oil-filled units with high thermal mass are increasingly popular. They take longer to heat up and continue to radiate heat after they're turned off. They're generally used for heating single rooms. Fan units can force air through a space and spread the heat out a little further. And infrared units emit electromagnetic radiation in the infrared spectrum rather than heating air in a room. They heat the surfaces that they're pointed at. They can be used in places where it's impractical to heat an entire space, such as an uninsulated garage or workshop. But typically they also use electric resistant elements, and while they're inexpensive to purchase, they are costly to operate. And again, they are often an indicator of other problems with insulation or with a heating system that's not working properly. Fireplaces are another form of direct heating system which supply heat directly into one space in a house. They're generally used more for comfort than as a serious source of heat, but they are nice to have, and people often use fireplaces for just a purpose of comfort or the benefits of fireplaces are a direct source of heating because they supply heat directly into one localized place in a house. They're generally used more for comfort than a serious source of heat, and they're not typically designed with efficiency in mind. They often result in a net loss of heat when they're used. Older chimneys can be a significant source of heating and cooling loss, and fireplaces can pose a number of health and safety risks, which are discussed in other places throughout the course. When they're not in use, fireplaces should have their dampers closed to minimize the heat loss up the chimney, and modern fireplaces tend to have improved dampers and liners that can help reduce air leakage. Wood stoves have much better overall efficiency, AFUEs between 63 and 78. Their performance is often dependent on the quality of stove and the fuel. Conventional wood stoves draft naturally and are not as efficient as pellet stoves. Newer high efficiency stoves use very efficient combustion methods and can reach AFUEs up into the 90s. They require some maintenance, but they save a lot of fuel and they burn very cleanly. And there are more and more types of fuels that are made of compressed sawdust and other biomass that can be made available for these types of units, and they can be a fairly efficient source of heating if they're installed properly and well maintained. Ducted or forced air systems are the most common type of central heating systems used in the United States. With this type of system, also called a forced air system, a furnace or a heat pump warms air and then a blower forces air through a system of ducts. The heating can come from electricity, an electric coil, natural gas or propane burner, or an oil burner. In some cases, with forced air systems, a cooling coil is also included in the blower, and this can allow the same system of ducts to be used for heating and for cooling. Let's take a look at the details of a typical gas furnace. Taking a look on the inside, you can see we have a gas line supply, so that tells us that it is a gas furnace. There's a system of burners at the base that heat up and heat the air in the combustion box. Air is introduced into this and then passed up through other units. Taking a look at how this actually works when it's in operation, when the thermometer or thermostat tells the unit to come on, the burners will ignite and begin to get hot, and typically they'll take some time to heat up the burners and the combustion chambers, and only after they achieve a certain temperature will the fan come on. And when the fan comes on, it begins to circulate air across the combustion chamber and up through the ducts in the house. Uh, if you remember in our discussion about air leaks, these units will draw air in from the house and force it through the house, and can also result in pressurizing the house and can contribute to air leaks. Taking a look at the bigger picture, as most of these systems have both supply and return ducts, and through the return duct, cooler air is drawn from different parts of the house down through the furnace. It's heated up in the combustion chamber and then distributed through a system of rigid or flexible ductworks to distribute that warm air to the rest of the house. Ductwork is an important part of a forced air system, and there's different types of ductwork, and they can affect greatly the overall efficiency of a system. Flexible ductwork is fairly inexpensive to install. It doesn't have a lot of joints, so it can not have a lot of leaks, but unfortunately, it's often not installed properly. It has lots of turns and can get crimped, and therefore add extra fan energy to move air through it. Round metal ducts are good because they have a lot less pressure loss, and they also, because of their smooth surfaces, don't collect as much dirt or moisture. Unfortunately, when they do leak, they're harder to fix, and they are more expensive to install, and they also require insulation. Fiberglass duct has some positives. It has good noise control, and it can be cut and fabricated fairly easily in the field and usually taped together with actual duct tape. These can have exposed fiberglass and can be harder to clean, but they do have fairly good insulation value. Now let's shift gears and talk about hydronic heating. And instead of moving air through the house, these systems will have hot water. Boilers are used to create hot water, and they can be fueled by oil, natural gas, propane, or electricity. A big advantage of hydronic systems is they tend to require less energy to move the heat throughout the home, because the pumps that pump the hot water generally use less energy than the fans in forced air systems. So let's take a look at a typical boiler and start to learn how we can spot what kind of a furnace we're looking at. In this case, there happens to be an oil supply from a tank, an oil pump, and a burner. There's a hot water return system that goes through a circulation pump and a hot water supply system that sends the hot water out to the house. You can see that the pipes are insulated in this case, hopefully retaining some of that heat. And the circulator pump is an important piece of this system. This is what pumps the water throughout the house. It requires maintenance from time to time. And also the exhaust vent is something that we'll take a look at. This is where carbon monoxide gases are being exhausted, and we would make sure that something like this is well sealed and doesn't have any leaks. Gas boilers are very similar in design, except typically instead of an oil line, you're going to see a gas line, like the yellow coil in this case. But they have very many of the same components as an oil boiler. An electric boiler functions a little bit differently. Also has a high circulation pump to pump hot water through the house. In this case, there's a hot water supply line coming out of the boiler. An expansion tank identified here helps accommodate the shrinking and contraction of water as it heats up and cools off. Here's the hot water return line that goes back into the boiler, and the electrical line, because the fuel for this unit is actually just electricity. Another popular way to distribute heat with hydronic systems is through the floor, and in this case the boiler is used to create hot water. In this case, probably a lower temperature water, more like 80 or 90 degrees, and the hot water is pumped through loops through the floor and delivered to the house in that manner. A heat pump is a heating and cooling system that uses air conditioning principles to extract heat from the outside and deliver it to the inside. An air source heat pump absorbs this from outside air, even when it's cold outside. This is a little bit counterintuitive, so let's take a minute to see how it works. A cold liquid refrigerant, which is located behind the expansion valve and the tubing outside the house, absorbs heat from the outside air, and it can do this because the refrigerant is much cooler than the outside air. As the liquid refrigerant absorbs heat, it evaporates, hence the outside coils are referred to as evaporator coils. The temperature of the refrigerant at this point is almost equal to the outside air temperature. The evaporated refrigerant gas is then compressed with an electric compressor to a higher temperature, and this is so that heat can then be transferred to the inside. The compressor is often thought of as the heart of a heat pump, since it does most of the work with electrical energy to force that heat uphill through the compressive cycle. As high temperature and high pressure refrigerant gas passes through the indoor coil, it gives up this heat to the inside air. And a blower unit circulates air across these coils and pushes that air through the rest of the house. And in some cases, when extra heat is needed on very cold days, there's an electric resistance coil to add a little bit of a boost of warm air to the work that the heat pump is doing. The fan also cools the refrigerant to a point where much of it condenses back into a liquid, and therefore in a heating system the indoor coil is called the condenser coil. This change in state also results in a big, substantial transfer of heat energy. Back outside, the warm refrigerant now goes through an expansion valve, and this device reduces the pressure, causing the refrigerant to become very cold again, and once again so cold enough that it's ready to absorb heat from the outside air and repeat the cycle. So this system can also be reversed to provide cooling in the summer. Heat pumps are considered low temperature devices because they're not capable of producing air much warmer than 85 degrees. And again, if it's very cold outside, they tend to need a little bit of a boost from an electric coil or other heating elements inside the house. In ground source heat pumps, the earth is used to exchange heat rather than outside air. Refrigerant is pumped through loops underground that are designed to be long enough to achieve a desired amount of heating or cooling. Ground source loops can be built through deep wells drilled vertically or by trenches and horizontal loops for the refrigerant. Active solar thermal systems include the use of a solar panel or collector on the roof that is used as a way to pump water and heat it. That water is then moved down into a storage tank and moved through a coil where either air or other water can be moved across it to gather active heat from the sun. In passive solar systems, the sun is allowed to penetrate inside the house and help heat the house without use of mechanical equipment. Passive systems usually make use of high mass materials that can store the heat and help distribute it over a period of time. And they're usually supplemental to other forms of heating systems in case there's not enough sun to provide the needed heating in the house, but they can often provide a significant amount of energy to reduce the use of fuels in the heating of a house.